I started pricing out what actually goes into a fully rigged center console wiring harness. Every wire, every connector, every breaker, every foot of network cable behind the console. Add it all up properly on a serious offshore build, and you're looking at a number that can easily push past $90,000. Not the boat, just what's running underneath the dash. Most owners never see any of it. It's buried behind a panel, and as long as the electronics turn on, nobody asks what's actually back there. Here's the number to remember: 7 inches. That's how far unprotected wire is allowed to run from a power source before it needs its own fuse or breaker under ABYC E-11, the standard that actually governs this stuff. 7 inches. Keep that number in your head, because by the end of this video, it's going to tell you exactly how serious a builder is about the part you'll never see. Let's start with the piece everyone assumes is identical across every brand: the wire itself. Marine Wire Meeting UL 1426 certification uses tinned copper. Not because the wiring standard demands it, it doesn't, and that's marketing shorthand people repeat without checking. Tinned copper is the industry-recommended practice because bare copper corrodes fast in a saltwater environment, and a corroded strand raises resistance long before it ever looks broken from the outside. Here's where the cost starts showing up. Owners who've priced both report a premium of roughly $2 per foot for tinned wire over bare copper on heavier gauge cable. That sounds small until you remember how much wire is actually running through a 40-foot center console, battery cable, bilge runs, live well circuits, helm feeds, lighting. Multiply a small per-foot premium across that much cable, and it stops being a rounding error. Budget builds skip this more often than you'd think. Automotive-style wire is technically allowed in a few limited spots on a boat, but it's restricted from bilge spaces, restricted from engine bays unless it's rated for heat, and never approved anywhere near constant vibration. Pull a panel on a cut-rate harness, and that's usually the first thing I check. Bare strands, automotive gauge, sometimes both, in a bilge, which is exactly where neither belongs. That's the cheap end. Now the part that actually separates a serious harness from a good-looking one. Connectors. A lot of console wiring never gets a sealed connector at all. It gets spliced, 2 wires twisted, capped, wrapped in electrical tape, and left to sit behind a panel that never gets opened again. That works fine for a season, maybe 2. Then salt air finds its way in, and now you've got a connection nobody planned to service, failing in a spot nobody planned to check. The alternative is a sealed, waterproof multi-pin connector. Deutsch connectors and Amphenol sealed multi-pin connectors are what you'll find on properly built harnesses, rated to handle full submersion without losing continuity. You'll find these at every major junction on a properly rigged boat: the console breakout, the live well pump disconnect, the helm harness split. They cost more per junction, and they take longer to install. But they're the reason a tech can pull one plug and swap a failed pump in 10 minutes, instead of tracing wire with a multimeter for an hour while you're supposed to be fishing. And where you can't use a multi-pin connector, the ABYC-compliant alternative is a heat shrink terminal, properly crimped and sealed, not just wrapped in tape. If you want one fast way to judge a harness without opening a single panel, ask your dealer this: are the console's connectors sealed, or are they spliced? A sealed connector keeps a failure contained to one circuit. A spliced, taped joint that fails leaves you guessing which of a dozen tangled wires is actually the culprit, usually offshore, at the worst possible time. Subscribe now, because the next part is where the real money hides, the layer almost nobody thinks about when they picture a wiring harness. Wire sizing isn't one calculation, it's 2. A properly sized wire has to pass an ampacity test to determine whether it can carry the current without overheating, and a separate voltage drop test to check whether the circuit loses too much power over distance. Whichever calculation demands the bigger gauge wins. and critical circuits like your bilge pump are held to a strict 3% voltage drop limit. Put a real number on it. A bilge pump 25 feet from the battery, drawing 5 amps, needs 10-gauge wire to stay under that limit. Run it on 14-gauge because it passes the ampacity test, and you've already failed the second half of the equation. Skip the voltage drop side, and here's what actually happens. Nothing fails outright. Your bilge pump still runs. It just runs weaker than it's rated for, quietly, for years, and you'd never know unless you tested flow rate directly against the pump's spec sheet. That's not a wiring failure you can see. That's a wiring failure you feel the one time you actually need full pump output and don't get it. If you've ever wondered why two boats with the same bilge pump perform differently, this is very likely why. It's not the pump. It's the wire feeding it. Now, the layer that quietly makes up the biggest chunk of that $90,000 number. The network. Every modern console runs on NMEA 2000, a backbone cable with T-connectors branching off to every device that needs to talk to each other. Garmin, Simrad, and Raymarine all talk on the same backbone, which is the whole point. Chart plotter, engine data, autopilot, depth, and radios share one network instead of running individual wires to every device. Individual network components run $20 to over $40 each, and a fully built-out helm can carry a dozen or more. Backbone sections, drop cables, terminators, and a dedicated power tap. Real money before a single sensor gets connected. It's also the layer that's completely invisible until something stops talking to something else, and now you're troubleshooting a network instead of chasing a single bad wire. Here's where it gets uncomfortable. Who actually builds this harness in the first place? Whether it's a Yellowfin, a Contender, or a Freeman, most center console brands don't hand wire boats from raw spools on the line. They specify a harness for a third-party manufacturer, built to their drawings and tested for continuity and voltage drop before it ever reaches the factory floor. That's not a shortcut. That's how the entire industry works, at almost every price point, from entry-level to flagship. So harness quality isn't really a story about the name on the hull. It's a story about the specification sheet that brand handed its supplier and how tightly the build matches it. Two boats wearing the same nameplate can ship with meaningfully different wiring. Quality if that specification changed between model years, or quality control slipped on one production run. That's the part you can't catch from the driver's seat. You'd need to pull a panel and actually look. Most owners never do, and the boat runs fine right up until the day it doesn't. So here's what it all adds up to. UL 1426 tinned wire instead of bare, the full length of the boat. Deutsch or Amphenol sealed connectors instead of spliced tape joints at every major junction. Heat shrink terminals where inline connections are unavoidable. Wire-sized for voltage drop, not just current, on every critical circuit. A properly built NMEA 2000 backbone instead of a tangle of unlabeled network cable. Breakers placed correctly instead of unprotected wire coiled behind a panel, hoping nothing chafes through. Blue Sea Systems panels and breaker blocks are what you'll find on serious builds. Not because there's only one right answer, but because a builder willing to spend on protection you'll never see tends to get the rest right too. None of those decisions is expensive alone. A few dollars here, a sealed connector there, a heavier gauge on one circuit. But price everyone out, correctly, across a full-size console, and that's how the number stacks into real money. Not because any single wire is expensive, because doing every single thing right, everywhere on the boat, adds up fast. Remember that number from the start. 7 inches. That's the maximum unprotected run. ABYC E-11 allows before a wire needs its own fuse or breaker. It sounds small. It's not. It's the difference between a wire that trips safely the moment something goes wrong and one that just keeps carrying current until it becomes the problem itself. Every decision in this video either respects that number or it doesn't. And that's really what you're paying for when you pay for good rigging, not the wire itself. The 7 inches nobody sees, done right, on every single circuit, every single time. Next time you're behind your own console, take one real look at how your wiring is actually run. You'll know in about 10 seconds whether whoever built it was thinking about that number, or whether you're the first person who's ever actually checked.